Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering a whole new topic called broken access control. Just like with the other theory videos, this is pretty much a brain dump of everything that I know about access control vulnerabilities, and so it's going to be a long one, but by the end of the video, you'll have all the fundamental knowledge that is required to complete the 13 hands-on lab exercises that we'll be covering in the next upcoming videos. Alright, before we continue with the video, I'd like to announce that this video is part of a course that I offer on my academy. Now you might be wondering, why would I buy a course that is made available for free on YouTube? Well, there are 4 reasons why you might want to do that. Number 1 is that you gain early access to recorded material. As soon as I record new videos, I make them available through my course right away, whereas on YouTube, they'll only be released on a weekly schedule. Reason number 2 is that you gain access to a Discord channel where you can ask questions. The Discord channel is divided into topics that we cover in the course, and if you run into any issues, you get to ask questions about anything related to the course material. Reason number 3 is that you no longer have to deal with YouTube ads or sponsor messages. And last but not least, reason number 4 is you get to support me. Any revenue generated from this course will go back into maintaining the academy and creating more videos and courses that will be made available for free on my YouTube channel. So if you're interested in buying the course, make sure to check out the link in the description. And that is it. Let's go back to our video. Alright, let's get started. The agenda for today is to first cover the technical details behind access control vulnerabilities. So what is an access control vulnerability? What are the different types of access control vulnerabilities? How common are access control vulnerabilities? And so on. Next, we'll cover how to find access control vulnerabilities from both a white box and a black box perspective. So if you're given an application and possibly even the application source code, how would you approach testing the application in order to determine that it's vulnerable? Once you have found that the application is vulnerable, how do you exploit the access control vulnerability to achieve your end goal? Then we'll end the presentation by covering the different techniques that you can use to prevent or mitigate access control vulnerabilities. Okay, let's get started with the first section, which is what is a broken access control vulnerability. Now, before we even talk about access control vulnerabilities, we need to go over some fundamentals. I do a lot of in-person trainings. I also have my own academy and my YouTube channel, and so I've taught this topic to a ton of software developers and security professionals, and I found out that most people don't have a proper understanding of certain fundamentals or certain terminology that are required to properly understand this topic. And so what we're going to do is we're going to first explain 3 concepts that people tend to use interchangeably as a single concept. However, these concepts couldn't be any more different. And the concepts or terminology we're going to cover are 1. Authentication, 2. Session management, and 3. Access control. Now, these 3 mechanisms are very much tied to each other. However, they're also very much their own separate functionalities and have their own implementations and serve their own purpose. And so it's very important that you understand the difference between them. And we'll start off by explaining the first one, which is authentication. Authentication is the mechanism that is used to identify the user and confirm that they say who they say they are. So let's say, for example, you've got a user who's named Alice, and Alice needs to log into her account on this application. Now, the application needs a way to verify Alice's identity before presenting Alice with all her information. And the way the application does that is using the classic form-based authentication. So it asks for Alice's username and password, and if Alice provides the correct username and password, it presents Alice with her information. So that's essentially all that authentication is. It's the ability to verify a user's identity. Next, we have session management, which is a little bit different. Once you've authenticated to the application, you want to visit other pages in the application. So let's say your profile page, or your change password page, or your accounts page, or so on. Now, all these pages are authenticated pages. And what that means is if you're not authenticated to the application, you shouldn't be able to view these pages. And that's where session management comes into play. Instead of you having to put in your username and password, so admin, every time you want to visit an authenticated page, which would be a huge hassle and terrible for user experience, the way the application deals with that is when you first authenticate, so when you put in your credentials, admin, it generates a unique token that is tied to your username that essentially acts as a short-lived password. And that token verifies your identity every time you make a request to the application. So this token gets passed by your browser in every request that you make to the application, and that all happens in the background. So you don't see it happening in the browser is actually doing that for you in the background. And this is why it is absolutely important to keep this token a secret. Just like you would keep your password a secret, because if an attacker gets access to this token, they can use it to compromise your entire account. But that's a whole other topic that we're hopefully going to cover in future videos. Now, to go back to our topic, let's recap what session management is. So session management is just a way to verify a user's identity across subsequent requests. And this leads us to the topic of the day, which is access control. Now, once you've authenticated to the application and gotten your session token, you want to perform certain actions in the application. Every time you perform an action, the application needs to determine if you are allowed to carry out that action, and that's done using access control rules. So let's say you, as the user Alice, would like to perform a banking transaction. When you perform that banking transaction, what happens is that your session token gets passed to the application, and what the backend does is it checks which user ID is this session token assigned to. Once the user ID is identified, it checks the access control rules in the database that have been applied to that specific user ID. If the user has access to the functionality that the user is requesting, then the request goes through. Otherwise, the request is denied. And that's essentially at a high-level overview how access control works. Now, there are 3 different types of access control. The first one is called vertical access control. This type of access control is used to restrict access to functions that are not available to other users in the organization. So think admin user and regular user. A regular user should not be able to perform the actions that a user with higher privileges, like an admin user, can perform. You can think of it as moving up a ladder in terms of your privileges, and that's why it's called vertical access control. The second type of access control is called horizontal access control. This type of access control restricts different users of the same privilege from accessing each other's resources. So for example, let's say you have Bob and Adam. They both have the same level of privilege in the application, which is that they're both just regular users. Now, Bob should only be able to access his data and should not be able to access Adam's data, and vice versa. And that's what horizontal access control rules do. They prevent users of the same privilege from accessing each other's resources. Since you're not climbing up the ladder in terms of privilege just like you would with vertical access control, but instead what you're doing, you're performing functionalities that you already have the ability to perform, but on other users' data, it's referred to as horizontal access control. The third and last type of access control is context-dependent access control. This type of access control is used to restrict access to functionality based on the state of the application or the user's interaction with it. So imagine you have a multi-step process for deleting users. The first step is to click on the delete button. When you do that, it initiates a request to the backend that asks you to confirm if you really want to delete that user. If you do, you click on the yes button and that initiates a second request that deletes the user. Now, context-dependent access control prevents a user from performing actions in the wrong order. So you shouldn't be able to right away delete a user without first confirming that you want to delete that user. Another example of context-dependent access control is a retail website that prevents you from altering the contents of your shopping bag after you've confirmed your order and made the payment. Now, if that type of access control has security holes, that could be detrimental to the organization. And the reason it could be detrimental is because what users could do is they could simply buy an item for, let's say, $1 and then confirm the order and pay for it, and then go back to that shopping bag, which should be locked but is not locked because it has access control vulnerabilities, and then they could put in that shopping bag $100,000 of items. Now, since according to the system, the order has already been paid for and confirmed, then $100,000 of items get shipped to the user that they don't actually have to pay for, which could be really detrimental to the organization. And this leads us to the main topic of this presentation, which is broken access control vulnerabilities. Broken access control vulnerabilities arise when users can act outside of their intended permissions. So for example, just like we saw, a regular user being able to perform admin functionality, or a regular user being able to view the personal information of another user on the system. Now, the impact of broken access control vulnerabilities really depends on the type of access control vulnerability that you find. Some of them lead to sensitive information disclosure, whereas others lead to unauthorized access or even modification or destruction of data. And we'll talk more about that later. I personally almost always find an access control vulnerability in every application that I've tested, and most of the time it's a vulnerability that is rated high or critical severity. So this is definitely not the type of vulnerability that you want in your application. Alright, so just like there are 3 different types of access control, there are also 3 different types of broken access control. The first one is called horizontal privilege escalation. Horizontal privilege escalation occurs when an attacker gains access to resources belonging to another user of the same privilege. Let's take a really simple example to explain that. Imagine Alice wants to log into her banking application, so what she does is she logs in with her account, and then the application presents her with her information. The way the application manages access to users' information or users' profile pages is through an ID parameter that is added in the URL and comes from the client side. So if the ID over here is 123, which is the ID of Alice, then it presents Alice with her banking information. Now, why could this potentially be an issue? Well, if I'm an attacker who also has an account on this banking application, what I could do is I could change my ID from, let's say, 121 to Alice's ID, and all of a sudden I have access to Alice's account. And to make matters even worse, since this ID can be brute forced, what I would do is I would brute force IDs from 1 to 1 million, and then I'd be able to compromise the accounts of all the users on the system. Now, this might seem like it's a silly example because the vulnerable parameter is in the URL and it can be changed from the browser. However, I've seen this quite often in many applications where the parameter is not in the URL itself. However, the parameter is hidden in a form field. And so if you intercept the request and alter that parameter in a proxy like burp, you're able to view the content of other users in the application. So the issue over here is the fact that the application relies on client-side input in order to make access control decisions. Now, client-side input should be considered dangerous and should be considered untrusted. Anything that is coming from the client should be considered untrusted. However, the application over here, what it's doing is it's relying on client-side input in order to perform access control decisions, and therefore it's vulnerable. All right, the second type of access control is called vertical privilege escalation. Vertical privilege escalation occurs when an attacker gains access to privileged functionality that they are not permitted to access. And the keyword over here is privileged functionality. So again, let's take a really simple example. Imagine you have an application that is used by both regular users and administrative users. If you're an administrator, you have access to the admin panel. If you're a regular user, you don't have access to the admin panel. And the way access to the admin panel is handled is again through a client-side parameter called admin. Now, when you log into the application, the backend database recognizes that you're an administrator, and so what it does is it sets that parameter to true and then requests the admin panel page. Now, since the parameter is set to true, you can access the admin panel. Now, again, what could go wrong here? Well, as an attacker who has regular access to the application, what I could do is just change the admin parameter from false to true and gain access to the admin panel. Again, that might seem like it's a silly example. However, we've actually been able to escalate privileges in applications, so in real-world applications, by simply manipulating parameters that were hidden in a form field versus parameters that were in the URL, just like this example right over here. Alright, the third and last type of broken access control is access control vulnerabilities in multi-step processes. So these type of vulnerabilities occur when access control rules are implemented on some of the steps but ignored on others. So if we go back to the context-dependent access control example, we saw that in order to delete a user, you had to go through two steps. The first step is the confirmation step that you really want to delete a user, and then the second step is the deletion step that actually deletes the user. Now, what software developers usually do, and I've seen this quite often in applications, is that they assume that the user is going to follow the intended sequence of steps. And so the user is never going to reach the /delete endpoint without first confirming that they want to delete a user. And so what software developers do is they usually put all the access control rules on this endpoint over here. So one, they confirm that you have to be authenticated, and two, they confirm that you have to be an administrator user in order to be able to perform this action over here. And since you can't get to this action unless you've gone through this action, then they don't put any access control rules on this endpoint over here and leave this endpoint vulnerable. However, that's not how requests work. You could request whatever request that you want in a proxy without going through the exact steps. And if there are no access control rules that ensure that you can't get to this step before this step, then you're leaving your application vulnerable to potential attacks. And that's essentially what we do. We verify that all the access control rules have been implemented on each step of the multi-step process, because attackers are not going to follow the exact sequence of steps. They're going to see if you didn't put certain access control rules on some of the steps because you assumed that a user would have to follow the intended sequence of steps. And that's essentially what access control vulnerabilities in multi-step processes is. Okay, so we've gone through the different types of access control and we saw examples of each category. Now let's go through other examples that we've come across in pen tests that fall in one or more of the categories that we just discussed. The first one is the obvious one, which is bypassing access control checks by modifying parameters in the URL or HTML page. So we saw an example of doing that in the URL, and in the lab videos, we'll see examples of hidden parameters that we can alter in a request to escalate our privileges, which is more like the real-world examples that I've personally seen in applications that I've pen tested. Another example is accessing the API with missing access controls on the post, put, and delete methods. That's where you implement access control on one method, but forget to implement it on another method. Again, that's something that we'll see in the lab videos. Third is manipulating metadata, such as replaying or tampering with JSON web tokens or a cookie. We'll see the cookie example in one of the labs. As for manipulating JSON web tokens, there's a whole module in the Web Security Academy that covers that, and hopefully we'll cover that in future videos. Fourth is exploiting cross-origin resource sharing misconfigurations that allow API access from unauthorized or untrusted origins. For this topic, I've got over 2.5 hours of content explaining exactly how to exploit course misconfigurations. So what I'll do is I'll link the videos in the description if you're interested in learning more about that. Last but not least, we've got forceful browsing to authenticated pages as an unauthenticated user. I see this one quite often. So in this type of attack, what you do is you try to enumerate and access resources that are not directly referenced in the application. Okay, so these are just a few examples of the common access control vulnerabilities that we usually see in web app pen tests, and we'll gain some hands-on experience in exploiting these types of examples in the lab videos. Now let's talk about how these vulnerabilities are introduced in code. Usually, it's just a matter of forgetting to put an access control check in your function, and this example on the screen demonstrates that. So what I would recommend is that you pause the video right now and try to figure out which line of code is vulnerable. Alright, hopefully you've figured it out, but if not, it's okay, we'll go through it together. So you could see over here, we've got a function called delete order. It takes in a parameter called ID, which is coming from the client side. If that ID is none, it says that the order is not found, so that's on lines 3 to 5. If it's not null, it gets the user that made that order, and then in line number 8, it deletes that order. Line number 9 just logs that the order was deleted for user ID so and so. Now the issue over here is with line number 8, it doesn't verify that the order belongs to the currently logged in user before it deletes it. And so the impact of that is any authenticated user of the system is able to delete arbitrary orders, including orders that are made by other users, which is not good. So you would have the ability to delete any order that you want, including orders that are made by other users. And the way to fix that is you would have to check if the order ID belongs to the currently logged in user. If it does, then the user should be able to delete it because that's an order made by that exact user. Otherwise, the user should be presented with a request denied response that prevents them from deleting the order, and that specific request should be logged because it's a clear attack on your system. So you could see over here, missing a simple check could be detrimental to your organization because in this case, it affects availability of certain resources in the application. And so if I'm an attacker who wants to deny access to orders of users, what I would do is I would try to brute force all the IDs of all the orders in the system and just delete them. And that can be done in an automated fashion that only takes a few minutes. And so you definitely want to make sure that you have all the access control checks in your code before it goes to production. All right, let's discuss impact of access control vulnerabilities. So we've touched a bit on that in the previous slides, but as usual, when I discuss impact, I like to measure it in terms of how it impacts the SIA triad, so confidentiality, integrity, and availability. Now, in terms of confidentiality, that's usually impacted because most access control vulnerabilities allow you to access other users' data. Now, if the access control vulnerability allows you to perform actions on behalf of other users, then it impacts integrity. As for availability, if the access control vulnerability allows you to delete resources, then it impacts availability. Now, sometimes when you gain access to an administrator account that has the ability to upload files on the system, you could chain two vulnerabilities together. So let's say a privilege escalation vulnerability with a file upload vulnerability to gain remote code execution on the host operating system. Just like I previously mentioned, most of the access control vulnerabilities I discover in real-world applications, they're usually rated at a high or critical because they usually impact all three, so confidentiality, integrity, and availability. And honestly, this should not come at a surprise because broken access control vulnerabilities are rated as the most critical security risk facing web applications today. What that means is that they're the most likely type of vulnerability to be found in applications and could potentially have the most impact. So if an attacker were to exploit the vulnerability, it would lead to detrimental effect to your organization. So definitely something that needs to be taken seriously and should definitely be checked for before code gets pushed into production. Alright, in the past couple of slides, we discussed what broken access control is, the different types of access control vulnerabilities, the impact of access control vulnerabilities, and how common and critical these types of vulnerabilities can be. In this section, we'll discuss how to find access control vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing this application to see if it's vulnerable? I've decided to split this section into two categories depending on the perspective of testing. The two categories are black box testing and white box testing. For those of you that have never heard of these terms before, black box web application pen testing is when the tester is given little to no information about the system. Usually the only information that the tester has access to is the URL of the application and scope of the engagement. Whereas for white box web application pen testing, it's the complete opposite. The tester would be given complete access to the system, including access to the source code of the application. Now, there's a third category that I haven't included on the slide. It's called gray box web application pen testing. This is a combination of both white box and black box pen testing, where the tester is given limited information and access to the system. So for example, instead of just giving the tester a URL to the application, the tester is also given accounts to the application. Now, when it comes to my methodology for finding access control vulnerabilities, I loop both gray box and black box pen testing into one category, and that's because my methodology is the same regardless of the category. If I'm approaching it from a black box perspective, my scope will be much more limited than the gray box perspective unless I find an authentication bypass vulnerability. Nevertheless, the methodology of testing for these types of vulnerabilities from either an unauthenticated perspective or an authenticated perspective, it's still the same. So for the purposes of this presentation, when I talk about black box testing perspective, what I actually mean is really a gray box testing perspective. So we're going to assume we're given a URL to the application and accounts from each privilege level. All right, let's start off with the black box perspective. The first thing that I do when testing an application is always map the application. What that means is I literally visit the URL of the application, walk through all the pages that are accessible to me within the user context that I'm running as, and make note of all the input vectors that could be potentially used to make access control decisions in the backend. This could be things like URL parameters, hidden parameters, and even cookies. And while I do all of that, I have my burp proxy listening silently and intercepting all the requests that I'm making to the application. Now, I would personally argue that this is probably the most important step when it comes to testing an application. Before you start poking parameters, you really need to understand how access control is implemented in the application, because that'll really pay off in the future when you're testing for access control vulnerabilities. And you want to do that for each privilege level. So when preparing the rules of engagement document, make sure to request at least 2 accounts of each privilege level. You want to request accounts of different privilege levels to test for things like vertical privilege escalation, but you also want 2 accounts of each privilege level, so of the same privilege level, to test for things like horizontal privilege escalation. Requesting these types of accounts will really help speed up the pen test, because without them, it becomes a matter of guesswork, which really, I think, wastes everybody's time. So it's really important that you make sure that you request these accounts when you're developing your rules of engagement document. Now, once you've understood how access control is implemented for each privilege level and the potential client-side parameters that are used to make access control decisions in the backend, then it's just a matter of manipulating these parameters to confirm if they are really vulnerable. And this can get really tedious because you want to do that for all the pages and all the parameters for each privilege level. So you could imagine how much work that would be to do manually. So instead, what you want to do is to use extensions like Authorize for Burp to automate a portion of that work. And we'll talk more about that in the next section. And that's essentially at a high-level overview how I would approach testing access control from a black box perspective. Alright, moving on to the white box pen testing perspective. The first thing that you want to do is review the code to identify how access control is implemented in the application. Now you have the ability to do that because you have access to the source code and you no longer have to guess it based on how the application functions, just like you would with a black box perspective. So if an application is doing access control properly, it usually will have a central application component that all requests go through that checks access control rules, and that the application denies by default access to resources unless explicit rules are put in place to give a user access. That's a proper way of doing it. However, that's not always the case, and that's what introduces access control vulnerabilities. So things that you want to look for are 1, violations of the principle of least privilege. So you look for situations where a system defaults to open versus defaulting to closed. So what you're looking for is a system that doesn't deny access by default. Next, you want to look for missing or weak access control checks on functions or resources. We saw an example of that in the Spot the Vulnerability Code exercise that we did in the previous section. Because the developer had missed putting a check in his code, any user on the system is able to delete all the orders that are made by all the users on the system. So what you want to look for is missing or weak access control checks on functions when you're reviewing the code. Next, you want to look for missing access controls on certain methods of the API. So there might be access control rules on, let's say, the get method, but the developer had forgotten to put access control rules on, let's say, the post or put or even the delete method. Last but not least, you want to look for instances where the application relies solely on client-side input to perform access control decisions. So not validating client-side input on the server side. Anything that is coming from the client side, just like we said in the previous section, should be completely untrusted and considered dangerous, and therefore should never be used to perform access control decisions unless it's validated on the server side. So these are the type of things that you want to look for. And if you see any potential access control issues, what you want to do is validate them on a running application to verify that it's really vulnerable. I've seen many cases where if you're only reviewing that function, it might look vulnerable, but somewhere in the million lines of code that this application has, or even the config files of the application, there might be an access control rule that makes it not exploitable. And so it's extremely important that you validate it on a running application. And that's essentially at a high-level overview how you would test for access control vulnerabilities from a white box perspective. Alright, let's move on to the next section, which is how to exploit access control vulnerabilities. This would largely depend on the type of access control vulnerability you're encountering. However, it's usually just a matter of simply manipulating the vulnerable parameter or the vulnerable field. So if it's a cookie, you would manipulate the cookie. If it's a hidden parameter, you would manipulate the hidden parameter, and so on. So instead of me going through all the possible access control violations, which would be a bit unrealistic, what I'll do is I'll save that for the lab videos. We have 13 labs split into 13 videos, and each one covers a unique access control vulnerability or a unique access control violation. So you'll gain plenty of hands-on experience exploiting various access control vulnerabilities, and I would highly recommend using this platform to gain that hands-on experience because it'll really solidify your understanding of the theory. Okay, so far we've only discussed how to do things manually. We can't end this section without mentioning web application vulnerability scanners, which are essentially automated tools that crawl your web application and look for vulnerabilities. Now, most scanners will likely miss access control vulnerabilities because each application has its own unique way of performing access control, and so it does require some human intervention. However, some of them, like Burp, can be configured to do that, but I usually don't use a scanner to test for access control. Instead, what I do is I use the Authorize extension in Burp to automate a portion of my access control testing. So the way that works is you would put your session tokens of your low privileged user, so your lower privileged user, in this box right over here. Then you log in as the high privileged user, so think an administrator user, and you browse through all the pages in the application manually while all the requests are being intercepted in your extension. Now, what the extension is going to do is it's going to make the requests that you're making in the browser, but it'll also make two additional requests. The first one is from an unauthenticated perspective. So it'll strip out the cookies and try to make the request from an unauthenticated perspective to see if you have an access control rule missing that doesn't require authentication in order to view the page. So that's the first request that it does. And then the second request that it does is it'll change the currently logged in user session cookies with the low privileged user session cookies. So the session cookies that you've entered right over here, and it'll perform the request again. Now what that's testing for is if you can perform privileged functionality. So that request should only be able to be performed from an administrator perspective or from a high privileged user perspective. And if you're able to perform it from a low privileged user perspective, then that's a vulnerability. Now, the way it identifies that is based on a few factors, but the main one is really the length of the request. So you could see over here, if the length is different, then the access control rule could potentially be enforced. However, if the length is the same, then the access control rule is bypassed, and sometimes you get the is enforced question mark result, and what that means, it's potentially enforced, but the extension is not sure. So you could see that it doesn't really automate the entire process for you. You still have to do a quick review of the list right over here to confirm that the results are actually correct, but it does significantly speed up the amount of time you need to test access control across multiple users. So instead of you having to do it manually 3 times, one from a high privileged perspective, the second time from an unauthenticated perspective, and then the third time from a low privileged perspective, you would only have to do it once, and the extension takes care of doing it the other 2 times. So I would highly recommend using this extension and checking it out. I might do a bonus video explaining how to use it on an intentionally vulnerable application. If that's something that you would like to see, just add a comment underneath the video, and maybe I'll do a video on that. All right, let's move on to the last section, which is how to prevent access control vulnerabilities. Number 1, and this is really important, is that you use a security-centric design where access is verified first and ensure all requests go through an access control check. So one of what we call positive patterns in the way access control is implemented is to build a centralized access control engine that all requests are forced to go through, as opposed to having to manually add checks in various places in the application. So let's take a really simple example. If you look at Java, it has authorization filters that can be configured in the web.xml file that only allow certain directories or certain locations of the application to be accessible by users of a specific privilege level. And this really aids into implementing the next positive pattern, which is a deny by default design. We talked a bit about that in the previous slides. So a deny by default design automatically denies access to a request when a policy for that request has not yet been set or configured. So if we go back to our Java filters example, you can configure Java filters so that all requests go through your access control enforcement layer. If a new feature or functionality is added to your system, that enforcement layer should automatically deny access to everyone unless specific access control rules are added to that feature. The next thing you want to do is always apply the principle of least privilege throughout the entire application. This one is pretty self-explanatory. Only give users access to the resources and privileges that they need in the application. And that's not just at the code level, but also at the configuration level. So when you're configuring an application, you should always abide by the concept of least privilege. Rarely does an application need system or root privileges to run, and so it should be run with a service account with limited privileges. I've gained remote code execution on several real-world applications, and when I gain remote code execution and I see that the application is running with system or root privileges, one, I get excited because I could further my foothold in the network. However, it also breaks my heart because no web application requires system or root privileges to run. And now, if a real attacker were to exploit this vulnerability, not only does the attacker have access to the server that is hosting the web application, but let's say if it's a Windows server and I'm running with system privileges, then I could dump the memory of the server, extract the hashes of all the logged in users, and then use these hashes to pivot to other servers on the network. And so it's extremely dangerous to configure your server without abiding by the principle of least privilege. Now next, depending on your application, maybe you want to consider making use of attribute or feature-based access control instead of role-based access control. Again, this highly is dependent on the type of application that you have. Now, the benefit of using attribute or feature-based access control is that it grants access based not on the user role, but on the attributes of each system component. So this type of access control may be more useful to you if you, for example, have multi-tenant applications that allow specialized groups of users to have specialized features of the application. This way, access control might need to be much more granular and therefore would be very complex to implement using role-based access control versus attribute-based access control. And so if your application requires that type of access control, you should definitely consider using attribute or feature-based access control. And then last but not least, and this is a pretty important one, is that access control checks should always be performed on the server side. So anything that is coming from the client side should be considered dangerous and should be completely untrusted and should definitely not be used to perform access control checks unless it's validated on the server side. And that's essentially how you would prevent access control vulnerabilities from being introduced into your code. Alright, we've reached the end of our presentation. I've added several really useful resources on the slide in case you're interested in learning more about access control vulnerabilities. In the next few videos, we'll gain some hands-on experience exploiting these types of vulnerabilities. If you liked the video, hit the subscribe and share button so that the video reaches a wider audience. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you and see you in the next video.